Let's consider the probability of a type 1 and a type 2 error, keeping in mind this is what a type 1 error is and this is what a type 2 error is. Okay, so let's say we have x is a normal distributed random variable with a mean of 100 and a standard deviation of 10. And we have a sample of 25 selected. So x bar is normally distributed with a mean of 100 as well, but it's going to be 10 divided by root 25 squared. So it's normally distributed a mean of 100 and a standard deviation of 2. Okay, so if we have our x bar, our sample mean, 100, and it's going to have a standard deviation for the sample of being 2. And HO is that the mean is 100, and that H1, the alternative, is the mean is bigger than 100. So a type 1 error is when HO is true, but we reject it. So if H1 is true, but we reject it. So if H1 is true, and I reject it, therefore I'm looking at a p-value here, which if it's bigger than that p-value, then it's going to be rejected. So type 1 error is this here. So if I was to consider what that value of x is, that gives me the critical point for a type 1 error, then inverse normal, right 0.052 and 100 is 103.3 to 1 decimal place. And that's using a 5% significance level. So the probability of a type 1 error is 0.05 or 5%, and that's determined by the significance level. And the probability of a correct outcome being a true negative, that is, the null hypothesis is true and we accept the null hypothesis, that's going to be 95%, because of course that's based on the significance level. Now let's think about a type 2 error. Let's say the mean was actually 110. That is the true mean. But we think it's 100 and we're testing. So given that the true mean is 110, and I'm going to consider this critical score that I got over here, which was 103.3. So 103.3, this probability here represents the probability of having a type 2 error. That I should have said the mean was 110, but I'm going to reject this situation and say that the mean isn't big and that I accept the null hypothesis, which is our type 2 error, the false negative. And that's the probability that x bar is less than 103.3, given the mean is actually 110, not 100. And that will be 5, and my mean is 110, because I know that is the true mean. So that probability is 0.1234264. So that's the probability of getting this result, and that result would indicate me saying that I'm going to have a value which is less than 103, and therefore I accept the null hypothesis when I should have actually accepted the alternative hypothesis.